Hello everybody, so the title of our project is called Njenje, and what we try to build is a dynamic, a tool that allows the user to get an understanding of their energy consumption for digital media in a dynamic sense. Now, let me motivate the reason for why we built this. Digital media technology is responsible for a lot of energy consumption on the planet, but there is little understanding how large the amount of energy actually is that's being consumed. And now from an organizational perspective, it's relatively simple to assess the amount of that energy, but what is difficult to find out is how much is being consumed by the machines that are operated by the user. And technically, the calculation is relatively simple. You can assume an average power consumption of a device and multiply that just by the duration that people spend while they're consuming a certain type of content. And that was the idea for Njenje. What we did was build a browser plugin which runs in a browser, which isn't, where is it? Here we go. Great. So we were interested in media websites, as for example, The Guardian. And so while I've got sorry about that.
It might be, if you just maximize it, it might be, yeah.
Okay, so what the plugin does, it tracks the navigation of a user through websites or tabs in the browser and calculate and creates a record of it. And then after some time, the user can open that little plugin pop-up and get a graph that displays how energy has been used by the system. I've got a bit of trouble with Mac. I don't know. Use 2 fingers. 2 fingers? No, won't do. Anyway, what there's a table underneath here which shows exactly for each page that or each tab that the user had opened, how much time the user has spent there, what the energy consumption of the device was responsible for the consumption of that content, and additionally there's a map displaying.
Talking to that.
And additionally, underneath there's a map which displays the location of the servers that provide the content of the pages, because even though this is an informative tool for the user at the moment to maybe initiate more behavior change. Okay, there you go. The location of the server is very relevant for the calculation of the carbon impact, because obviously the grid mix by which these machines are being powered depends very much on where they are. So in its current form, it does not pull in that data about the grid mix automatically from data, for example, from Amy, because we found that there was a bit of technical problems with that. So there are 2 things that this tool can go further. One is to develop it further towards a user information tool inside behavior change, and the other thing is to investigate more for a media company how users consume that content, how much time they spend on individual pages, and then calculate an overall organization footprint. That's all.
impact of their online activities?
Yes, that's a possibility. Now, for us, the first step is to understand how people behave when they consume the internet. We've got an intuitive notion ourselves, but we don't really know how people do that. So once you know that and how much video content, for example, they consume, you can then change the content towards it having a smaller footprint, for example.
And what could they do differently, I guess? I'm wondering.
They could, if they're aware, so it depends directly on the duration of how long they consume certain content, and that directly ties into idle power consumption. It's absolutely obvious to everybody, but making that dependency more transparent maybe can help people turning off their computer sooner rather than later.
There's a final column which is carbon. Are you going to link the data to sort of data on what the servers, whether they're powered by, so whether they're powered by renewables? Because then you then end up with a kind of way of showing people who are the most energy intensive and CO2 intensive sites. So
exactly. At the moment, so what we've got developed in research outside of this is a model of power consumption, including the network and the servers, and we want to tie that all together. Yeah? This is just a hack towards that end. But you're right. You can combine that with the energy information.
Could you tie it also into feedback? So if the content's been delivered by a part of the clouds, could you get, as a user, could you tell the servers, I'd much rather it came from some green energy source than some high carbon intensity source? So you follow the sun and create some dynamic link back into the cloud.
Almost an extension of like low power mode for the way
to use consumer pressure, because it might be more expensive to deliver from a lower carbon source, but if your user base is saying, well, we'll go and choose to use a lower carbon source, and we'll watch another advert in order to do so, or something like that. Then.
Yeah, good point. Now, the reality of the digital media universe on the planet is that the content doesn't come from a central server anymore, that it's being delivered by content. Yes, exactly. So there is leverage to exactly go towards that direction, but the APIs for the content delivery aren't there yet. But this is a very good idea.